This is a video abstract for the paper published by Osorio and others in 2022, published in Signal, Image, and Video Processing. So I will explain briefly the main idea of the paper. So SSIM is a coefficient to measure similarity between images X and Y. So assume that we have two available images called X and Y. So the SSIM coefficient is defined as luminance between images X and Y times contrast between images X and Y times correlation between the images, this to the power alpha, contrast to the power beta, and the correlation to the power gamma, where alpha, beta, and gamma are parameters. So traditionally, this coefficient has been used assuming that alpha is equal to beta is equal to gamma equal to 1. So from 20 years ago, all engineers have been using this coefficient, assuming these assumptions. So we would like to transform this to this problem to an hypothesis testing problem where the H0 hypothesis is alpha equal to beta equal to gamma equal to 1 versus H1 that H0 is not true. So the idea is to use the data available for images X and Y to provide an hypothesis testing to decide if this hypothesis is correct. In the paper, we use methodology maximum likelihood estimations, but based on a nonlinear model. So the model we use here is a nonlinear regression model that is defined like 1 divided by root mean square error between images X and Y. This is SSIM times e to the power u, where u is a white noise sequence with mean 0 and variance sigma square. So pseudo likelihood is used to approach this problem. So in the paper, we developed some numerical experiments to explore this coefficient in this way, this nonlinear model. We developed some Monte Carlo simulation to get more insights into the performance of this hypothesis testing, for example, in terms of the power of the test. And also, we do some application with SAR imagery to gain more insight how this process, this hypothesis testing, works in practice. So I kindly invite you to read the paper.